So number 91 talks about this graph, and it has this line that goes through the y-axis at some point, and it goes through the x-axis at some point, and they label them both. And then we know for a specific point that it goes through the point 2, 1. Now it's asking us to find the equation of the area of this shaded region here. So it asks us to write the function of the area as a function of x. So what does that mean? Well, what that means is that we have to determine just what exactly it is that we need for area. It equals 1/2 the base times the height. Now if we have that information, that'll be good, but the problem is that this line is differing because we're not very sure exactly where on this line it goes to the y-axis or the x-axis, but we do know that it goes to this point. So we could have multiple lines and we could still have, you know, a different triangle. So I could have it go through that point and I'll have a totally different triangle here. So the question is, how can I write it for any x given certain things? Well, I'm going to write it in terms of this x-intercept, because this length here is going to be the base of the triangle, and this is going to be the height of the triangle. So this is my height. So our height is here. I'm going to use this x, and it's not very clear about where I go from this. But I do know one thing, that if I have these 3 points on the line, if I have the point 0b, which I'm going to call 0y, to 1, and x0, if they're all on the line, then they all have to have the exact same slope. So the slope between these two points has to be exactly the same as the slope between these two. So how does this help us? Well, if I take the slope between these two, I get 1 minus y over 2 minus 0, or 2. That's got to be the exact same thing if I take the slope between these two. So if I take the slope between those two, I get 0 minus 1 over x minus 2. So we have those two slopes equaling each other. Now it might not make sense to do this yet, but what we need is a way to find y, because the y is a matter of finding height, because it's length times height. So what I need to do for this now is I need to solve for y. So I got to get rid of this y, so I'm going to times both sides by 2. So I times the numerator by 2, so I get 1 minus y equals a negative 2 over x minus 2. I'm going to subtract 1 to the other side, but I need to give it a common denominator, so I'm going to times it by x minus 2. So this has to be x minus 2 as well. So what I'm left with is a negative y equals negative 2 minus x minus 2 over x minus 2. Excuse me, this has got to be a plus 2 because of the negative 1 here times a negative 2. So these cancel out. So what I'm left with is negative y equals negative x over x minus 2. I'm running out of room, but what I am left with, if I change the sign on this, I have to make this whole thing negative, and I can just change the sign for two of them, and then it'll change to the same thing. So I'm left with y equals x over x minus 2. So you might be asking, what did we do and what was the purpose of this? What did this allow us to do? Well, what this allowed us to do, it allowed us to create a way to find, this helps us find a y value for any x value we choose. So now it doesn't matter which x value we choose, wherever it is, we know what the y value is going to be with it. Okay? This is the relationship between the two. And the y corresponds to the height of the triangle, because that's how far up the triangle goes. So to find area, you take 1/2 the length, which is x, times the height, which is x over x minus 2, and you simplify that by multiplying where you can. This is a numerator, this is a numerator, and you multiply that numerator, so you get x squared over, here's a denominator, and this factor is a denominator, so it's 2 times x minus 2. And there is your area function.